Residential market is for living hubs, personal cottages, and so on and so forth. And the main similarity is that when you are looking at the architectural glass and residential glass, the requirements and what the people do want usually quite similar in terms of requirements for IG unit characteristics, meaning light parameters, so light transmission, light reflection, and the U value. But similarity ends here. Residential IG units are usually quite many times smaller. They usually lack special treatment, the glass there, in these IG units, like tempering, heat strengthening, and so on. That makes them easier and cheaper. But if you're offering an IG unit to the residential market, be prepared, the customer will be much more picky, so can have much more questions, because usually he is not aware about the glass parameters and glass capabilities. If you're talking to architect or a facade company, these guys dealing with the glass on a regular basis, some of them for many years, they know what the coated glass is, although not all the time. But the customer who came to buy new windows is usually completely unaware about what he's going to buy, why does he need it, and so on. As we're talking, if we are proposing glass on a big residential building, we again come to architect, we come to the facade guys and explain them on their own language. But if the customer picks for himself, his knowledge is minimal, usually. And that leaves him in the mercy of a salesperson. And if the salesperson is experienced enough, he basically can sell anything. If the customer knows nothing about the building, me personally, I can convince him to buy anything I want, like from coated glass to a triple IG unit without any coatings. That is lying on me. And again, next step is that residential customers are very picky on the visuals and usually will present you a lot of claims, some of which are not the claims at all. Okay, so with this introduction done, let's go and see what does the customer wants. So customers wants usually natural daylight. In some summer region, in some southern regions, he may want very few daylight, but we can offer him a different product. He wants to have a comfort, so be comfortable in summer and in winter. He wants money saving, but frequently he doesn't know that he can save using the coated glass in an IG unit. He is simply not aware about that. And all the customers are wanting zero problems during the lifetime of the window, door, IG unit, or a glass wall in case of some kind of cottages. So let's start with the natural daylight. There we have a very broad range of characteristics combined. For a residential market, we will be either using our sun-cooled glass, non-temperable version, so a little bit different from a tempered ones, but there we have a full range. In some cases, we're having a life glass. That's the double silver product developed by our factory, which is designed especially to be used in residential applications. Cannot be tempered and have a very good characteristics. In comparison to the similar products of AGC and Guardian, for example, life glass offers you more light transmission and In the same time, we will see that in right here, very low solar factor. And the combination of light transmission, high light transmission, and low solar factor, and also low reflectivity, makes this IG unit almost ideal for the residential applications. Here, an example, the numbers are given for a triple IG unit. So again, in comparison to the competitors. So this one you can remove because this one is available only on the Russian market. Sorry, forgot to remove this from the presentation. What does the customer says about, first, about light transmission? This glass will be darker, but how much? As you can see, the difference between triple IG unit and triple IG unit with our glass is less than 10%. And you may ask, is it a lot or not? The easiest way to explain this to the customer is to give him comparison from his real life. So that is how less than 10% looks like on a real live photo. This is no Photoshop, it's just IG unit with normal glass and compared to them, the residential live glass. So here on the Moscow skyscraper, you can see the difference because these are located each other, near to each other, close to each other. But to the customer, you can explain it in the following way. You see, if you have a balcony without any coatings, and you will not be washing the glass from outside for about half a year. And there, between these two washed and unwashed windows, the light transmission difference will be about 10%. So 10% is something you have between, if you wash one part of your window and leave the other unwashed, there you have a 10% difference between light transmission. Easy way to the explanation, and also that gives the customer satisfaction that, okay, this is not a terrible loss. And then you may go on and explain what he will gain from using a coated glass in his IG unit. I understand that most of you are from the southern countries where winter comfort is not a thing, but I will try to give you some interesting numbers regarding what do we gain in the winter. So if again, we take it in the cold zones where you frequently talking about triple IG unit. So first, which the customer gain is the U value. Without any coatings, triple IG unit, 1.7. Meanwhile, double IG unit with one coating and argon gives you 1.1 or 1.0. Okay, one IG unit without argon, one coating, 1.1 again. We're talking about triple IG unit here. Additional low E drops the parameters even lower. And the top, we have triple IG unit with two coatings and argon inside. The U value is 0.6. So heat loss through the window is reduced 3 times. We only added 2 coatings and some argon. The next question of the customer would be, is it worth my while to using this? The first thing is sure, because in the winter time, not only U value, that's the number the customer is frequently not aware of. So what is the U value? He doesn't know. But what he knows is his feeling near the window. So let's imagine that inside you have plus 20 and outside minus 19. For Russia, it's normal winter. On a triple IG unit without any coatings, the temperature of the inner glass will be about 7 degrees. That is cold, and that will also cause an inner convection inside the room. The air inside the room, when it's come in the contact with the glass, it cools down and goes down. And there you have it. You have air circulation inside your room. If you will be sitting your back to this cold window, the air will flow right in your back, and you may even get ache in your back for sometimes after sitting like this. Meanwhile, it will not be comfortable. So you will be having air movement without any outside air coming. If you put even one low E glass, temperature will increase almost to 12 degrees, much more comfortable. And with the edge unit fully packed with low E glass and argon, it will be around 15 degrees. Much more comfortable to sit near the window. And that is what defines a winter comfort for a person. So all of his walls, including window parts, will have a uniform temperature. Now, this is especially important if the customer have something like a cottage with where he will be living with the glass walls where he will be living during the winter. So Finnish cottage, like we call it here, or some other, which are looking extremely good in the promotions. But in fact, if you don't offer enough heat protection, they can be quite uncomfortable ones. In turn, if you're planning a living building, again with the glass walls, and many of the newest Russian residential big houses having this feature, this is again becoming a very important issue. So for the loss of a little bit of light, customer gains a lot in terms of comfort in the winter. But the good thing for the cold climates is that you convince customer with numbers. Let's imagine that you're having a cottage, something along these lines, with the 20 square meter of glazing and located in Europe. Now, this cottage can be heated with electricity, one option, wooden pellets, second option, and gas or oil boilers. That's the third option. Now, let us see how different IG unit compositions can work with this and how much money a person can save per heating season. The comparison here is quite easy, and mathematics also quite easy. So you have a different IG unit compositions, starting from double IG unit with argon and low E, and ending with triple IG unit with 2 coatings and argon also attached. Now, by simply comparing a U value of this, we can estimate the heat loss through 20 square meters, which will be going through the heating season. Now, of course, this varies from climate zone to climate zone, but here I took Germany, just as an example. Here you have a heat loss in kilowatt hours and percentage in comparing to the option A. And here we can calculate savings on different type of heating, depending on the price for heating in each type and the efficiency. And there we get it. If the customer with this cottage has an electrical heating, mind you, the least cost-effective one. But when the customer sees that during the winter time, from his 20 square meters of glass, he will be saving 266 euro. And that immediately will bolster his interest by a lot. Because if he replaces one, he chooses one type window over the other, the cost difference, he will make it in no time. 2-3 years, something like that. Again, this is regular savings. But even if we take into account more efficient energy heating solutions, like heating with wooden pellets or oil and gas boiler heating, the numbers are less effectively looking, but they are still considerable. So 100 euro is a 100 euro, even if it goes for a heating season. So in here, customer might be wholly convinced that the heating will save his money. If we will be, such calculations of energy efficiency can also be done for a big residential project, for any climate zone. You just need to convince that the person, if you will be installing these IG units in your windows, then the whole building, and if we take not 20 square meters of glazing, but 1,000, the numbers would be quite convincing here. So where we do have heating season, it usually, if you're showing something along these lines, it's usually quite effective way of convincing the customer that by choosing a better and more expensive option in the beginning, starting after several years, he will beginning to save and gain money instead of continuing losing it. This is the, I think, standard calculations for energy efficiency, which we do for many projects. Quite easy, and then you can compare your IG unit compositions between each other, and in terms of not only kilowatt hours, but in terms of money. Now, okay, winter comfort is easy, but what about the summer comfort? There we need to make one major distinction. Distinction being that during the summer, you gain heat not only by the sun, but you also get heat by direct heat transmission. For example, if your facade of your building is facing north, so you will rarely see the sun here, really. But if you have plus 40 outside, that means that the heat from the hot air will be going inside your building, not with the sun, but through direct transmission. And again, to fight against that, again, you need a U value. What is the better thing for summer comfort is that air conditioning is usually more expensive than the heating one. More expensive option, I mean. So in the summer, customer usually wants the level of daylight to remain on almost the same level, while he wants much less solar heat to come in. Again, if he wants protection from direct sunlight, it is wise to install some regulating devices like blinds, curtains, something along those lines. So if you want, you open them. If you don't, just close them. But in form of IG unit, the combination of natural daylight and much less solar heat gain can be provided only by soft coated glass applications with the special solar control and low V coatings, like SunCool, Live Glass, or the products of our competitors. I will not be naming them, but here you go. I will repeat myself a little bit from the previous webinars. So how do the glass gets the properties that it transmits a lot of light, but it doesn't transmit a lot of heat? You see the sun is shining on us with the visible spectrum. So that is the part of the solar light that we are seeing, so visible light. But sun is also shining on us with a lot of solar heat, which we do not see because it lies in the infrared spectrum. Thereby, it brings us only problems because it heats us but doesn't give us a visual comfort. The coating composition is done in the following way. So in the top, you see the blue graph. That's for the flowed glass. It transmits a lot of light. Here is the level of transmission on the ordinate axis. And it does transmit a lot of solar heat. By choosing the proper coating composition, we make the glass selective. That means the glass with the coating will transmit a lot of radiation in the visible spectrum, while reflecting back a lot of radiation in the infrared spectrum. And that is why it selectively transmits parts of the spectrum. That is why we call it selective. So for the customer, you can easily explain it because he is not a specialist. You can easily explain them, okay guys, coating is multi-layered. These layers are made in the following way that it transmits light but stops solar heat, which you don't need. That would be truth, and that would be the easy explanation what the soft coated glass is and how it works. And now, again, I will show you the table with this selectivity. So selectivity is very simple. It is light transmission divided by solar factor. Simple as that. The highest selectivity, one of the highest selectivity is on Pilkington products. If we will be comparing SunCool glass, the results would be much the same. Okay, let us see about how the IG unit with the soft coating behaves itself during the hot season. Here on the map, it's easily seen which parts of the world are affected by the cold climates and which are not. So yeah, Russia is all blue. Starting from October, and yeah, till March basically, and April. If we're talking about Australia or Mexico, then oh yeah, it will never get in the cold zone. So here you don't need to worry about winter UV value. But let's go and see some numbers. Now, for the hot climate zone, I've chosen, instead of Europe, I chose Australia. So let's talk about Sydney, for instance. So for the calculation of the energy efficiency in terms of solar radiation, we have to know how much solar heat is falling on the vertical surface. Now, this piece of data is the most difficult to find because you see the modern internet is dominated by the solar panels. So you can find how much solar heat falling on the horizontal surface almost everywhere. Vertical, more difficult, but of course doable. Then we take a solar factor of your IG unit and take the cost of electricity. And using this information, we can estimate the savings on the solar factor, so summer savings. Excuse me. In this table, you can see several IG unit compositions without triple IG units, of course. And starting with the lamination with the gray glass body tinted to start with. So laminated with the gray glass. And then we compare them by the solar factor we're going to have in the end. Basing on how much solar heat is falling on 1 square meter, we can estimate the heat gain from November to April. And we can see how much does the air conditioning cost. Now, in this step, we would require one additional number called a cooling coefficient or chilling coefficient. This is depending on your air conditioning equipment. The less efficient being the ordinary home systems for air conditioning, and the most efficient would be the sophisticated systems which incorporate the whole building, which are used in the big projects. Depending on the type of project, we can estimate what would the cooling coefficient would be. And then we can easily calculate the estimated saving on air conditioning in dollars, Australian dollars, per this period. Now, as you can see, in comparison to the standard laminated solution, the IG unit with the special solar control glass from the November to April will save about $400 on air conditioning. That is also based on assumption that air conditioning will always be working. Of course, if you turn it off during daytime, savings will be less, but if you take an office building, that would be the number you will be looking at. And with these numbers of hand, it's also quite a good way of convincing a customer to go for more energy efficient solutions. Mind you, you can also present a light transmission of all of these units. So the light transmission of gray float would be only a tiny bit, like 7% higher than the sun-cool one. So the difference is even more visible. And there you have it, the savings on air conditioning. The numbers are much more impressive in this case. But that's not it. That's not all, I mean. We do not only have, as I've told you, a solar heat, as we are having a direct heat transmission. Again, and yes, by the way, this all have been done for a same 20 square meters of glazing. Now let's look at the climatic data for Sydney for summer and see how IG units glass will fare in this case. Most important here would be the temperature difference. So the average temperature around 29 degrees, but of course in the summer it is more. But I took the pessimistic approach. Air conditioning cost is the same, and here we will be looking at the U value. So the U value of a laminated glass is very bad. And yeah, mind you, the U value has been calculated specially calculated for the same temperature difference on which we will be looking. So these numbers are quite different from a standard U value calculations. Here you can see that only on the direct heat, the only direct heat savings in comparison between this composition and the composition with SunCool will be around $75 per year. So not that impressive like a solar factor, of course, because direct heat gain gives you less energy coming, but it adds up. So in the end, what we can tell the customer if he wants to buy an IG unit for his cottage, that, okay, guy, you go for more expensive solution, you save $500 per year simply on air conditioning. Now, $500 is quite a convincing number in this regard. The main idea here being that the customer can not only be convinced by discounts, something, but he can also be convinced by his comfort and by the savings on air conditioning. Another thing is the temperature comfort in summer. Let's go a little bit back here, this table, and see the U value. If we compare the temperature inside, the inside temperature of the inside glass in terms of heating, we will see that difference between this number and this one would be almost 10 degrees. I think I should have put it down on this table, but 10 degrees is a lot. If you come to, okay, like I did in Singapore, in Vietnam, if you're coming to a window even in the commercial buildings, a lot of them are glazed with simple laminated glass. You touch the glass, it is hot, especially if the sun is shining on it. So that means hot glass radiates heat as directly onto you. And even if you're sitting under the air conditioning, it can heat you up. So the temperature of the inner glass is also important here. And that is temperature given by the U value. But by solar factor, of course, also by direct sunlight. But the U value also does matter. So if you compare laminated glass solution to the IG unit glass solution, IG units win. Our coated glass can be laminated and used as a laminated solution. But again, if you laminate the coating to the film, you are immediately losing all of its emissivity. So low E properties, gone. Only solar control remains. So the U value of a laminated glass with soft coating or without soft coating is absolutely the same. Low E is not working. Okay, we've done looking at the convincing part. Let's see and talk about some problems which in the residential market usually faced by the customers. And the first problem is condensation. Here you have, I want to ask you a question. Here you have two different photos of different IG units. But on the left photo, the central part is clear and the edge zone is covered with water, condensate. On the right photo, it is directly opposite. So the edge zone is clear and the center is foggy. Now, could you give me an idea what is the difference between these two? Why are they behaving absolutely different? What are the conditions? What are your ideas? Now I'll wait for about a minute. So if you have any ideas, feel free to write in the chat. No? Okay. Nobody knows? Okay. The difference, in fact, oh yeah. Luis, no. Nope. Warm edge spacer versus no warm edge. No, in this case, it's not. But thanks a lot for giving ideas. The actual answer is that in the left picture, we have a condensation in the inside of an IG unit, so in the room. And here on the right picture, inside hot temperature, yeah, you're basically right. And in the picture to the right, we have a condensation on the outside of an IG unit. Yes, cold outside. Right, sure. Cold outside is the left picture, and different picture on the right. So, if the customer, yeah, and this is of course explained that the IG unit will having a central zone. The central zone is defined by the zone in which your spacer does not affect the properties of an IG unit. Edge zone, where you have the influence of the spacer quite visible in our case. So here is the condensation on the outer glass. And that is, if the customer complains about this one is easily explainable. First one, you say, okay, dear customer, you have a condensation on the outer pane, yes? As you know, water from the air first condensates on the coldest surfaces, right? Yeah. If you have a condensation on the outside of your IG unit on the outer glass, that means it was very cold or cold. And if it is cold, that means that there is precious little heat which is coming from inside of the building to this glass, which in turn means that your IG unit have a very good U value. So it is very good at keeping heat inside the building. That means you're having an excellent IG unit with the excellent heat protection. So why are you complaining? And by explaining this simple physics, it usually leaves the customer quite satisfying with how good an IG unit he's having in his building. And of course, the condensation in the central zone and no condensation in the edge zone means that in the edge zone outside is hotter because a lot of heat coming through the spacer. And central zone, yeah, very good one. Besides, this usually happens in the morning and after the sun gets up, it usually dries out quite quickly. The condensation is inside is a little bit worse. It usually happens in the cold climates, of course. So inside is hot, outside is cold. So, and here, a lot of heat is going through the edge zone, through the spacer. That means if we're looking at the edge unit from the inside of our building, the edge zones are much colder. And depending on the conditions in the room, you may have condensation. If the customer complains about this, you will have to check the humidity. You have to check the temperature near window. And you can advise him to check the resin on the perimeter of his window. Because if the resin is not good enough, the seal is not good enough, then cold air may penetrate your window and blow directly through, thereby causing parts of your window to be colder than the other. And of course, if the customer have a from inside complaints, you can advise him to check if the hot air from the heating devices can get to the window at all. Sorry. For example, if your window is usually closed by the blinds, curtains, that means that hot air from the room cannot get to the window, cannot get to the glass. And as soon as you open the curtains, all of the water will be condensated on the inner surface of your window, or of your IG unit, of course, also. And that also means that the better the U value, the bigger the temperature of the inner surface. At the bigger temperature of the inner surface, the less problems you will be having with the inner condensation. On the contrary, the better the U window, the U value of your window, the more outer condensation you might be having. But as I've explained to you, that is not a terrible thing. As you can see, I've made several some calculations for the how does the ordinary window perform. On this picture, you are seeing here the edge zone of with an ordinary aluminum spacer, and here you can see a calculation result for a warm edge spacer. As you can see, the cold zone, so from blue to green, is much bigger and much wider on an aluminum one. And the edge zone is looking much warmer and better with the warm edge. So if you are trying to promote your IG units and windows in the colder climates, it is usually advisable to use a warm edge in this case. Now, do you frequently use warm edge spacers, or you think that from your position aluminum is quite enough? I want to understand that from your experience. So please feel free to know me in the chat, to let me know in the chat. And meanwhile, let's talk a little bit about this photo. And this photo, you can see a special ventilation which is made for the window to be always hot. So here you see the heating element is under the window. And this area is quite big. So if the ventilation hasn't been made like this, then hot air will be having a very long road to get to the window. And the bottom zone of the window, the bottom, would be much colder. So for the cold climates, this is the usual solution with which you're usually going to achieving better results and less claims. Next up on the list, we will very briefly touch the thermal shock because it deserves its own webinar. But the thermal shock is quite frequent on the southern parts and on the residential glass, simply because for residential applications, glass is very rarely used as temperate. Okay, not very rarely, but much more frequently than for architectural IG units. So thermal shock usually looks like this. And you can always identify it by the beginning of the crack. So the crack always starts from the edge, and in the point of origin, here it is perpendicular either to the glass edge and to the glass plane. So the start is always 90 degrees, both to the plane and to the edge. Thermal shock is the destruction of the glass, or crack in the glass, caused by uneven heating of the glass. One part of the glass is hotter than the other. And when the glass heats up, as almost all materials, it tries to expand. And that leaves us with the tensions on the border between hotter part and colder part. For non-tempered glass, if you don't do an edge work, that is a cause for many cracks, from my experience. Now, what affects the risk of thermal shock? What can cause it? So, the bigger the energy absorption of the glass, the worse. So, if you use body tinted non-tempered glass, or if you put in a colored film on it, then you are in the risk zone. If your IG unit or the glass have a heavy shade falling on it, that gives your glass uneven heating. One part of the one area of the glass will be hotter than the other. There you go. And of course, curtains, blinds, which will obviously doing the same thing. The worst case scenario is when you are having your blinds going like this. So halfway down. That means that you are again doing an uneven conditions for the top and the bottom part. And especially it is bad when you're having a bright blinds, like a white ones. That is because white blinds reflect a lot of light and heat back because they are very reflective. And that causes the glass to heat even more. So you know how to identify the thermal shock by the crack region. You know why it is happening. But about the thermal shock, we'll be talking in detail and in depth in its own webinar. So instead of that, I am moving to the next one. But before I will move on, one more thing. If you're in your IG unit, you are using a solar control soft coated glass like Suncool, Life Glass, what does it give to you? It reflects back a lot of solar heat. That means it transmits inside a lot less solar heat than usual. And that actually helps you to lower the risk of thermal shock on your IG unit, because it will be not heated as much. Helpful? Sure. And the last one, we will be looking at the breakage because of the climatic load. Again, this is only for IG units, and that is because during its lifetime, the IG unit is breathing, so-called breathing. That is because between the glass, IG units have a gas gap filled with gas. If you heat it up, it will expand like this. If you cool it down, it will shrink because the volume will be either decreasing or increasing, and the glass will be bending to compensate this. But first thing that you will be notice, the glass will not break, but first you will start see the optical distortion on the facade. So here, in a very good example of how the facade can be looking quite bad if the IG unit composition was not properly chosen. But I've covered this in the 3-part webinar. You can go on the YouTube channel and take a look at it. It calls how to design an IG unit. But what if the glass cannot move to fully compensate the pressure, the excess or deficit of the pressure? Then IG unit will break because of the climate load. Now, the climate load can be defined can be, you can see that the glass will be, was broken because of the climate load, because climatic load usually have this very distinctive cross pattern. So on the square of IG units, it's like this. You see, the pattern is quite visible. If your IG unit is not square, the cross pattern remains. So here, you see, it's like this. Again, quite visible. Why it is the pattern is looking like a cross or like a sand glass for that matter? That is because if we take a look at the stress calculation, the biggest bending you having in the center of the glass, and geometric center is of course the point where diagonals are crossing each other. So you have biggest stress and biggest deflection in this very point, in the central zone. So if we take a look here, the same cross pattern can be applied. So if you see the glass which was broken down like this, then it's almost for sure this is the climate load. Now, what factors are affecting this? First is height to width ratio. Now, that is very simple. If the IG unit resembles a square, then maximum glass bending, maximum glass deflection is determined by the shortest side. If both sides are the same, the bending is quite big for its size. But if one side of the glass is very small and the other is very big, then the ability of the glass to bend by this compensating the deficit or excess of the pressure is quite limited. And where the glass cannot bend, it starts to gain stress, and stress causes the glass to break. Same applies for the wide spacer. The wider the spacer, the more gas you have between the glass. The more gas you have between the glass, the more will be gas deficit in case of winter, or the more will be pressure if the IG unit is heated in summer. For the winter climates, you can also install the IG unit in the non-heated building and leave it for the winter. And if not heated up, the temperature will drop drastically. That can also cause the glass to break because of the climate loads. So recommendations, in addition to that, the temperature, do not install it to the unheating buildings. Advise you to perform stress calculations if your IG unit is wide, long and not wide. And if you have a small IG units, then because of the glass size, they cannot bend. So they will accumulate a lot of stress. In case you want to protect yourself, you can dull the glass edges. So do a little dulling. And don't use wide spacer. For the hot climates, it's really not necessary. For the cold climates, completely different situation. But for the hot climates, 12 to 16 millimeter would be enough. And the golden rule is that for most IG units, in most cases, if you're using spacer wider than 16, you better be having good reason for that, because you are not doing your IG unit any good. U value usually worse, risks many, deflection, and by the way, optical distortions bigger. So in most cases, bigger spacer meaning more problems, not less.